Today, we're going to be talking about Python generators. Generators are extremely useful and a somewhat complex concept, so let's get right into it. A generator is a function that retains its state between function calls. For example, consider the following function. That function will always return 1, no matter how many times you call it. But if we make that function a generator, it will return 1 and then 2. Why? Because generators retain their state between calls. So the program will stay at the first return and then move on to the next one. Variables inside a generator also retain their state. This means you can use generators to yield continuous patterns of variables indefinitely or even, when done correctly, in cycles. The first main difference between a normal function and a generator syntactically is that generators use a yield syntax instead of the normal return. Consider the function from before. If we replace the return statements with yield statements, it becomes a generator. Now this function will have the behavior described previously. It returns 1 and then 2. That is because the function will retain its position in the program, so once it has executed the first yield, it will move on to the second one. Generators can't just be called like normal functions, however. This is because they are iterable. Let's take this generator that continuously yields the Fibonacci sequence. We should see it begins by initializing the variables a and b to 0 and 1 respectively. Then it enters a continuous while loop and yields the first variable a, and then proceeds to perform a Fibonacci operation where it sets a to b and b to a plus b. This means that this function will continuously and indefinitely yield the next value in the Fibonacci sequence. In order to call this function, we first need to get its generator object. You can do this by calling the generator as if it were a function. This will return the generator object. Then, you can use the next function to get values from that generator. As I said previously, generators are iterable, so we can even use for loops to loop over them. Here, let's look at an example. This code returns even numbers between 0 and 10 in pairs of 2. Using a for loop, we can extract those values. That will print out all the results of the generator. Notice that we will still have to get the generator object back from the function before we can iterate over it, but we don't need to initialize it to a separate variable. A final note about generators is that they can be infinite. This can be problematic if you have an infinite generator like the Fibonacci example shown previously, as when you use a for loop to iterate over it, it will effectively create an infinite loop. This is why you should default to the next syntax shown earlier when dealing with infinite generators. That way you can control the number of values you can extract. So that was it. That was generators in a nutshell. As you can see, they are an extremely useful tool in your Python toolbox, and when used correctly can be extremely powerful. Anyways guys, that was it for today's video, and yeah, I'll see you all in the next one. Bye!